Hey everyone, welcome back to your math class, and today we're going to get into another review lesson. We studied fractions last time in lesson number 2. Today is lesson number 3, and we're going to do a review of decimals. So the plan for today is we're going to talk about a few things relating to decimals. We're actually not going to do the word problem, the last step. I've decided to spare you guys today, and my reasoning for that is that with the initial assessment that I gave you guys, which was basically something like an exam, it took you guys 2 classes, a lot of you, and it was some really hard material. We started from fractions and decimals at the beginning, and we went all the way up to algebra and trigonometry at the end. So it was a lot of stuff. I'm sure it was a bit of a stressful experience for you guys. So I'm going to give you guys a little bit of a breather after doing that and then doing such a long lesson last time. It was a little bit over 40 minutes and you guys had a few practice problems in there. So today we're just going to talk about decimals and sort of some of like the theory of like how it works to do math with decimals. So we'll talk about how to do decimal addition, subtraction, multiplication, and division. We're going to talk about the names of the place values for decimals because that's something that a lot of people tend to struggle with if it's not discussed properly. So I want to spend a few minutes on that as well. Towards the end, we'll talk a little bit about things like repeating decimals, and then I just want you guys to kind of keep this lesson in the back of your mind as you go into the weekend. Maybe rewatch it if there's some things that you're not sure about. Of course, if this is all super easy for you, then just sit tight while we finish this review. And then next lesson, we'll do more practice questions involving decimals. We'll work through some problems, and then we'll get into percentages after that. So if you see on the screen here, we're going to talk about when we use decimals, just like we did last lesson with fractions. We're going to talk about the place value names for a couple minutes. We're going to talk about how to go through addition, subtraction, multiplication, and division problems involving decimals. We'll talk about repeating decimals, and then briefly we'll just touch on the fact that there exists a connection between decimals and percentages, which most, if not all of you, should already be aware of, but we'll just touch on that as well. And then, like I said, we're going to skip the word problem for today. We're going to skip the practice questions for today. And the reason for that is that when we do decimal addition and subtraction, it's not that complicated. It's very, very similar to regular addition and subtraction with whole numbers. But when it comes to decimal multiplication and division, I think that's a topic where maybe it's useful to spend a little bit more time doing a few more practice questions. And so I want to be able to dedicate more of a class to going through the problems after we've already talked about sort of how to do the problem. So we'll briefly review all of these things in the next class, but we're going to talk about them in greater detail today, and then we'll do more actual like examples and practice in the next lesson. So first things first, when do we use decimals? So just like fractions, we use decimals to talk about things that we can't use a whole number to describe. So when we want to talk about something that's like, for instance, between 0 and 1, so more than 0 but less than 1. We don't have the whole thing, but you don't have none of it. It's somewhere in between. Or anything that's something that you can't use a whole number to talk about. So something could be between 5 and 6, could be between 49 and 50, could be whatever. Anything that is between two whole numbers, you could use a fraction to talk about it, you could use a decimal to talk about it, and depending on the situation, you might use a percentage to talk about it. So one thing that I want to really stress when it comes to doing math with decimals is that I don't want you to feel afraid of decimals. So you'll see in the second point, let me get my laser pointer there. Decimals behave a lot like regular numbers when it comes to addition, subtraction, multiplication, and division. So I'm assuming you guys already can just add, subtract, multiply, and divide whole numbers. Doing like long addition, long multiplication, all that stuff. So under that assumption, you technically also already know how to add, subtract, multiply, and divide decimals. It's just, it gets a little bit confusing in certain cases where exactly you should put your decimal point or how many digits are after the decimal point in your final answer. So I'm going to spend more time on that when we're doing the practice problems to make sure you guys really understand, like, if I throw a certain number at you that's got a 0 in a bit of a weird place, like how does that change the question? Things like that that might throw you off just a little bit, that make this a little bit different from working with just regular whole numbers with these 4 basic operations. Yeah, other than that, they're basically the same. So we'll spend a little bit of time to make sure that you guys are good with that, and then after that we'll jump into percentages, like I said, for next lesson. So you can also see here I've said decimals are basically representing the same idea as fractions, in that we're talking about representing parts of a whole in a sense, except when we're talking about decimals, you're always talking in terms of the pieces that you're breaking the whole into. They're always broken into chunks that are what we call powers of 10. So it's either like 10 or 10 times 10, which is 100, or 10 times 10 times 10, which is 1,000. So like when you see a number written as a decimal, you've got a whole number and then you've got some additional part that's left over after the decimal point, and that leftover part you can technically write as a fraction, as something over 10 or something over 100 or something over 1,000, depending on how many digits you have after the decimal point, which we're going to see in a little bit more detail on the next slide. And then I just want you guys to keep this in mind for now. We're not going to really talk about it today, but decimals are also closely related to percentages, so we're going to get into that next class as well. And in the next lesson or two, we'll start doing a lot of practice questions and like word problems and stuff involving decimals and percentages, and then maybe throwing in fractions and decimals into the same problem and things like that. So now I want to spend a couple of minutes talking about place values. So these are things that you guys will probably be familiar with, this left side of the decimal point. So here, right here is our decimal point, of course. Everything on the left side is probably something that you are already familiar with. So the digit that's closest to the decimal point, but on the left side, is in the ones place. The next digit over is in the tens place. The next digit over is in the hundreds place, and the next digit over is in the thousands place. So you've probably seen something like this before. Now, when I was in school, I'm not sure if you guys have used these or if you guys have these nowadays, but when I was in school, we used to build we used to have these blocks that would let us build the numbers using these like ones, tens, hundreds, and thousands places. So the ones place would be represented by these teeny tiny little cubes. I can make that a cube. And so basically each of these little teeny tiny squares represented 1. So if you wanted to have like 9 ones, you would draw out 9 of these little cubes, or we used like the actual physical little plastic cubes, so we would collect 9 of those little cubes. And then when it came to the tens place, you'd have these little sticks that were made up of 10 of the little cubes. So hopefully you guys have seen something like this before. So you'd have like this little stick that's made up of 10 of these little cubes. So that one stick represents 10. And so if we have a 2 in the tens place, that means we need 2 of these sticks. And then the hundreds place was a grid of 100 of those squares, a 10 by 10 grid making a big square. And then the thousands was a cube, which was the same size as the hundreds square, but it was 10 squares deep as well. So it had 1,000 of those teeny tiny cubes that we started with over here. So I'm not sure if that's something you guys have seen before. If it's not, and this is just confusing you more, just ignore that. But so you should be familiar with the ones place, the tens place, the hundreds place, and the thousands place. But if you've worked with these before, you've probably only done it for ones, tens, hundreds, and thousands. Probably nothing bigger than that. But you don't really do it for the decimals, and it gets a little bit weird to start talking about decimals and then not have these kinds of blocks to use to describe what's going on. And then you read these names like tenths instead of tens and hundredths instead of hundreds. And it's weird. It confuses people because like here the tens place is the second digit away from the decimal point, but the tenths are the first digit on the other side. So like it gets really confusing for a lot of people. So I want to explain how these numbers kind of work. I'm just going to get rid of these things over here so that I have a little bit of room just to declutter the screen a little bit. But so I want to talk about this. If we look at this whole number, so this is 3,129.31303. That's the number that we have on the screen. I tend to be a little bit of a stickler for this, but obviously you're not going to be docked marks or anything if you say it differently from me. Whenever I'm reading out a decimal number, you're always going to hear me read the left side of the decimal point as like the number, like 3,129. But then after the decimal point, it's just reading out digit by digit by digit. So I wouldn't say, for instance, for looking at just after the decimal point, I wouldn't say 0.31,303. That's not how that works, because we're not talking about thousands and hundreds. We're talking about tenths, then hundredths, then thousandths. Like it's a whole different thing. So it's not right to say like 0.31, because 31 is, that's the tens place and the ones place, but we're talking about the tenths and the hundredths. So I'm not going to be a stickler for that if you guys will end up saying it differently. Of course, there's exceptions when you're talking about like dollars and cents and things like that. But I want to break down these names here. So on the left side, we've already talked about it. It's pretty obvious. You've got the ones place. That's just each individual one of those like little squares. The tens place. So so whatever digit you have here, that represents how many groups of 10 you have in your number. So it's not just a 2. This is a 20. Right? Plus this 9 over here, that makes this 29. And then the number in the hundreds place, that represents how many groups of 100 you have in your number. So this is one group of 100, so that's 100. Two groups of 10, so that's 20, so that's 120. And then 9 ones, 9 groups of 1, so that's just 9, so 129. So that's how that works together. And then same thing with the thousands, that's 3 groups of 1,000, so that's 3,000. One group of 100, so 3,100, two groups of 10, 3,120, and then the 9, so 3,129. On the other side of the decimal point, we've got these weird names that go in the other order. They start at the tenths, then they go to the hundredths, then they go to the thousandths, going in that direction now. So the idea here is that after the decimal point, if you just had this one digit, if we just ignore these last 4 digits, this 1303, and we just looked at this, just the 0.3. So the idea here is this is saying that we have 3 tenths. We have 3 things that, 3 teeny tiny pieces that if you put 10 of them together, you would get one of these. So if we have, again, I'm going to redraw these even though I erased them. If we have one of those little squares that represents one, whatever we're talking about, one sugar cube, just because it's a square, we're going to call it a sugar cube. So you've got one sugar cube, and then for, this is the 10 sugar cubes, and then the 100 sugar cubes is the square, and the 1,000 sugar cubes is the cube, the really big cube. So the tenths is something that's so small that you need to stick 10 of them together to get one of those. So you could picture it as like a teeny tiny little sliver that if you stack 10 of those on top of one another, you'll make one of these. So that's the idea behind the name tenths, that you need 10 tenths to make one, right? It's like we have the word there, tenth, but this is also, for instance, this is 1/10, the fraction, right? So if you had 10 tenths, well, that's just 1, right? So that's the logic behind this name tenths right here. And then same thing goes for the hundredths, that you need 100 of these. You need 100 hundredths to make 1, right? So it's the same logic. It's like having, I'm going to write it up here. It's like you have, this is 1/100th. So if you had 100 hundredths, that's just the same thing as 1, right? So that's how that works. And every step, it follows the exact same pattern that you have up here, where you need 10 ones to make a 10, right? You need 10 of these to make a 10, and then you need 10 tens to make 100. Forgive my writing. And then you need 10 tens to make, 10 hundreds to make 1,000, right? So it's the same idea on this side of the decimal point. Oh, that's my laser pointer, not my eraser. On this side of the decimal point, it's the same idea. You need 10 tenths to make 1, and you need 10 hundredths to make a tenth, and you need 10 thousandths to make a hundredth. So it's always going by tens. It's always going by tens, and then obviously you can make those bigger jumps as well, that you need 100 hundredths to make a 1, right? Or you need 1,000 thousandths to make a 1. So the names of these things is how many of them you need to put together to make 1, right? So that's the idea behind the naming here. I hope that clears it up a little bit for those of you who might have been confused by it. I remember when I was in math class, a lot of my classmates, a lot of my friends, they would really struggle with this idea, and I'm sure I struggled with it as well, but of course now that I understand it, I don't remember that as well. But this is one of those things that if it's not explained to you well, it's something that you'll kind of always be a little bit unsure of when you're talking about it. So I wanted to take a couple of minutes to explain it. Of course, if you have questions, if you're not understanding, if I didn't explain it very well, leave something in the comments. I'll either answer it there or I'll make a short snippet of a video to explain just that. All right, now let's get into decimal addition and subtraction. So here it's pretty straightforward. So decimal addition and subtraction can be done just like regular addition and subtraction. The only extra step that you have to make sure of, so normally when you're doing addition problems, you have to line up the ones place, right? If you've got two numbers of different length, like a different number of digits, if you've got like 1, 2, 3, 4, so if you've got like 1,234 plus 56, then you line up the 5 and 6 such that the digits in the ones place line up with each other, right? So that the 4 sits directly on top of the 6. You write it so that those line up with each other. So it's basically that same idea. The tricky thing with decimals is that you don't always have the same number of digits after the decimal point. So if you look at this case here with our addition problem, we've got 12.5, and that's the end of the number, plus, just getting my laser pointer, so we've got 12.5, that's the end of the number, plus 6.23. Now, the important thing here is to make sure we line up the decimal point. So this decimal point sits on top of this decimal point, which sits upon the decimal point in our answer. Again, we've got the ones place sitting on top of the ones place, sitting on top of the ones place in our answer. And the reason this gets a little bit tricky is because of this situation that we've got going on after the decimal point. In the first number, in this 12.5, we've only got one digit after the decimal point. And in the second number, we've got 2 digits after the decimal point. So a lot of people might write, instead of putting the 12.5 like that, they might put the 12 here, the decimal point here, and the 5 there, right, sitting on top of this 3. But then it's just weird. You've got a decimal point right here, and then you've got a decimal point right here, and then where does the decimal point in the answer go? I have no idea anymore, right? So that's why I wanted to talk about this briefly, is that it's just like regular addition and subtraction, except you need to make sure you've got the decimal points lined up. And then if you line up the decimal points, that takes care of everything else. Here we've got the digits in the ones place lined up. Here we've got the digits in the tenths place lined up, and then it just works from there. In subtraction, it's the same idea. You try and line up the decimal points, which automatically handles lining up the ones place and the tenths and the hundredths and whatever. And one thing I just wanted to kind of highlight here is that this number was originally basically just 12, right? It's 12.00. That's like, if it was dollars, that's just $12. There's no cents there, right? But one thing that's useful to remember here is that if you don't have the same number of decimal digits, you can always just stick zeros on the end of it, and it means the same thing. So like I could put in our addition problem, I could put a 0 right here, and I haven't changed that number, right? 12.5, 12.50, 12.50000, they're all exactly the same number. So if it helps you kind of remember to line them up, you can put zeros in the number that's got less digits after the decimal point until you've got the exact same, so that it's easy to line up. And when it comes to doing subtraction problems, it really helps to write in those zeros so that you can borrow numbers the way that you normally would in a long subtraction problem, because otherwise you're looking at 12 minus 8.13. And now you've got to take away this decimal 0.13 away from a whole number 12, and it gets really confusing. So write in this 0.00 after the 12, and then now you've got your standard long subtraction problem where you've got 0 minus 3, so you've got to borrow from the left, and then that's a 0, so you've got to borrow from the left again. So the 2 here becomes a 1, and then that becomes a 9, that becomes a 10, and you do your subtraction problem just like that. So hopefully that's clear. That's one very, very common mistake, so I wanted to make sure that that's something that we nip in the bud right now, rather than it becoming a problem on a test, because this is supposed to be easy marks. When it comes time for our fractions and decimals test, this is supposed to be easy marks. The harder questions will be the word problems and the ones where I throw fractions and decimals together in the same question, but regular decimal addition and subtraction is the easiest thing you're going to find on our test, because it's so similar to regular addition and subtraction. Now let's move on to decimal multiplication and division. So we'll talk about these topics for a few minutes as well. We'll start with decimal multiplication. That's the only thing that's on this slide. And you can see what I've written here. Decimal multiplication and division work like regular long multiplication and long division. So I've taken this example just off Google Images because it does a nice job of kind of highlighting the steps that you want to take when you're doing a long multiplication problem. So if this wasn't decimals, if we ignored the decimal points, this question is basically oh, that looks like a Z. Let's not do that. This looks like 256 times 2, right? If we ignore the decimal points, then we don't need to write this 0 anymore, and it just looks like 256 times 2, which if you were writing it out as a long multiplication problem, you would do 2, 5, 6, and then you'd put your 2 here, and you can do your multiplication problem pretty easily from that point, right? 2 times 6 is 12, carry the 1, 2 times 5 is 10, plus 1, that's 11, carry the 1, 2 times 2 is 4, plus 1 is 5, and you get 512, right? So there's your answer if it was a regular long multiplication problem. The difference when it comes to multiplying involving decimals is, first things first, you don't need to line up the decimal points for a multiplication problem. You can actually just ignore the decimal point completely and do the multiplication problem as if there were no decimals there. You don't have to worry about that. The second step is you want to count out how many digits you have in your original multiplication problem that are after the decimal point, even though you ignored the decimal point to do the calculation. So you do this calculation, you write down the 512 that you got here. Now you have to count out how many digits you have after the decimal point in both your terms. So we've got 2.56, that's the 5 and the 6th. We've got 2 digits after the decimal place. In 0.2, we've got just the 2, so that's just 1 digit after the decimal place. So 2 plus 1, that's a total of 3 digits after the decimal place. After the decimal point. So in our final answer, we're just going to make sure we also have 3 digits after the decimal point. So it's as simple as that. You count out how many digits are after the decimal point in your two terms, and then you just match that number of digits after the decimal point in your final answer, and that's it. So in this over here, we would of course throw the decimal point right here. And then if you like, you can put a 0 in front of it. You don't have to. I tend to make a habit of it because if you can't really see the decimal point, then you're going to read this as 512. But if you put the 0 there, you'd never put the 0 there if it was a whole number. So this is telling you that, you know, if you make your decimal point really tiny, then maybe you can't see it very well. But if you put the 0 there, then that's your signal that we're writing a decimal here. So you'll read that as 0.512, and you're not going to mistake it for 512. So that's it for decimal long multiplication, just like regular long multiplication, except we have to do this counting exercise at the end to match the number of digits after the decimal point. So now we're going to move on to decimal division, and this is the exact same thing as regular long division, except all you have to do now is when you write your quotient on top, after you've set up your long division problem and you're working through it, now you have to line up the decimal point. So basically, long multiplication, when it comes to working with decimals, that's the only one where you don't have to worry about lining up the decimal point. But for addition, subtraction, and long division, it's probably a good idea to line up your decimal point. So if we were to just sort of work through this problem together, I'll rewrite it on the side so that, because that's a lot of steps to look at all at once. So that's a little bit big because we can already see how long the problem is going to be. So let me make that a little bit smaller and we'll work through it kind of quickly because I'm sure you guys can just read what's on the left, but I want to go through it in steps in case this is a little bit overwhelming, because when you have a lot of math already worked out for you, then it can take a little bit of work to figure out what's going on. So here's our problem. And we start by asking ourselves the question we always ask ourselves in long division. While you're working through the question, you can just ignore the decimal point. We'll just make sure that we put a decimal point. Honestly, we can even put it right now in our answer. We know it's going to sit right above that decimal point. And now we just do the regular long division problem. So we ask, how many times does 5 go into 9? That's once. 5 times 1 is 5. So we're going to subtract 5, which leaves us with a 4. And now you don't have to worry about the decimal point from our original question. Just ignore it. Just pull the 6 down right here. And then we ask ourselves, how many times does 5 go into 46? That's 9 times. 5 times 9 is 45. So we subtract 45, which leaves us with a 1. Pull down the 7. 5 into 17, that's 3 times. Sorry for my writing. Minus 15. And one thing I'd like to highlight here for you guys as well is if we get down to this, just 17 minus 15 is 2. Suppose we didn't have this 0 written into our problem originally, and it was just 9.67 divided by 5, and then you run into this situation where you've got a 2 by itself and 5 doesn't go into 2. But now you can't write that we have a remainder because we're trying to solve this problem fully, right? We're trying to write out the actual decimal answer. It's not 1 remainder, blah, 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 blah. It's 1.93 something. We want to get a really specific answer. So if you didn't have the 0 here, we already know that from a couple of slides ago that you can just add in a 0 if you need to, and it doesn't change the number. So we can just add in a 0 right here, and then that's the 0 that's going to get pulled down all the way to here. And so then we've got 5 into 20, that's 4 times. 5 times 4 is 20, so we subtract 20, and we're left with 0. And now we're done. So that's it for this type of a question, and then you get your answer, 1.934. How do we decide where to place the decimal point? We just line it up with the decimal point in our original question. And that's all there is to it. One thing I'd like to note for you guys as well is that when you're multiplying and dividing by powers of 10, this is something you've probably noticed when working with whole numbers before, that like, for instance, 12 times 10 is 120. You just tack on a 0 to the end of it. 12 times 100 is 1200 or 1200. So that's 1200. You just tack on those 2 zeros to the end. When you're working with decimals, it's the same idea. It's just now you can think of it more as moving the decimal point around. So you can see it on the slide here. So when you're multiplying or dividing by powers of 10, it actually basically just means moving the decimal point left or right, depending on whether you're multiplying or dividing. So the direction that you move the decimal point depends on whether you're multiplying or dividing. You're going to move the decimal point. I don't know why that's wrong in the example. That shouldn't be 52.9 times 10 is not 52.9. That's wrong. That's in the example. But so when you're multiplying, you're going to move the decimal point to the right. And when you're dividing, you're going to move the decimal point to the left. Now, how many places do you move it? Do you move it 1? Do you move it 2? Do you move it 3? It's the number of places that you move the decimal point is going to be the same as the number of zeros in the number that you're multiplying or dividing by. So for instance, if you're multiplying by 10, 10's got 1 0 in it, so you're going to move the decimal point 1 space to the right if you're multiplying, or to the left if you're dividing. If you're multiplying or dividing by 100, 100 has got 2 zeros, so you're going to move the decimal point 2 spaces. 2 spaces to the right if you're multiplying, 2 spaces to the left if you're dividing, and so on. So for 1,000 it would be 3, for a billion it would be 9, you know, whatever. And if you look in these examples, so this is, of course, this one is wrong. Sorry for the typo. So 52.9 times 10. So because we're multiplying, we're going to move the decimal point to the right. And we're going to move it 1 spot to the right because 10's got 1 0 in it. So instead of 52.9, that's going to be 529. Now, I'd like to pose a question to you. I wasn't going to cover this lesson, but because I've already made a mistake with the example, what if this was 52.9 times 100 instead of times 10? So 52.9 times 100. So because we're multiplying, we're going to move the decimal point to the right. That's no problem. But we're supposed to move it 2 places. But we don't have 2 places. We only have 1 digit after the decimal point. So same thing as I've said a couple of times, we can just invent a little 0 that sits after the 9 so that now we have 2 places, and we can move the decimal point 2 places like that. And so we'll get a final answer of 5,290. So that's something I wanted to touch on as well, that you guys know that if you are multiplying by a number that's got so many zeros, but you don't have that many zeros, or that you don't have that many digits in your original number, then you can just tack on zeros to make up the difference if you need to. Now, the rest of these examples should all be right. So here we've got 29.184, and we're multiplying by 100, so we're going to move the decimal point 2 spots to the right. So it goes from being after the 9, it goes 2 spots to the right, it goes to being after the 8, so we've got 2,918.4. That's where the decimal point ends up. Now, if you're dividing, the decimal point's going to move the other direction. So we've got 184.4 divided by 100. Now, 100 has 2 zeros in it, so the decimal point's going to move to the left 2 spots. So that becomes 1.844. And if we're dividing by 1,000 in this last case, the decimal point is going to move 3 spots to the left. 3 spots because 1,000 has 3 zeros, and to the left because we're dividing. So 4,298.34 becomes 4.29834. So now we're just going to talk very, very briefly to round out this lesson. We're going to talk about repeating decimals. So you're going to notice, especially if you punch numbers into your calculator, certain division problems, certain fractions, excuse me, you're going to notice that sometimes your calculator spits out a repeating decimal. It spits out a lot of digits, and sometimes those digits repeat. Sometimes it's just one digit that repeats. So for instance, if you punch in 1 divided by 3, or like 1/3 the fraction into your calculator, and you ask it to give you the answer as a decimal, it's going to say 0.33333 until it runs out of space on the screen of the calculator. It's just going to give you 3's up until then. Or if you've got a really fancy calculator, it'll say 0.3 and it'll put this little bar on top of the 3. And that means the same thing as this over here. Having the bar over one digit or a few digits means that that digit or those digits are going to keep repeating forever. So 1 divided by 3, that's 0.3333 forever. It might give you the dots, it might give you the bar, it might just say 3's until it runs out of space. But sometimes it's not just one digit that repeats, sometimes it's a whole bunch of them that repeat in a sequence. So for instance, if you punch in 1 divided by 7 on your calculator, or the fraction 1/7, and you ask it to give it to you as a decimal, it's going to give you 0.142857, 142857, 142857 forever and ever, basically until it runs out of space. And it can be hard to spot because a lot of calculators will run out of space like here, so you can't really see the entire string repeat. But that's just one of those things that with a little bit of practice, you'll start to figure out that like, oh, you know, when I divide by 7, there's a chance that I get that. When I divide by 3, there's a chance that I get something like this, right? And similarly, if we're repeating all of these digits, 1, 4, 2, 8, 5, 7, then you stick a bar over top of all of them. That means that it's going to be 1, 4, 2, 8, 5, 7 again and again and again and again. So that's how that works with repeating decimals. I just wanted to touch on that briefly. And that's it for that section. And this is the last thing that we're just going to talk about very, very briefly today. I've decided I'm going to go into more detail in the next lesson. I just want you guys to remember that decimals and percentages are closely related. I know I mentioned that at the beginning. I wanted to mention it again now because it's something that's going to come up soon, and I don't want you guys to forget that that's true, that decimals and percentages are related to each other. So you'll often see that they're exactly the same string of digits. They really look almost the same. It's just the decimal point has moved around a little bit because we're multiplying or dividing by 100. That's not really the case with fractions, because you'll have a fraction like 1/4, but as a decimal that's 0.25, and as a percentage that's 25%. So it looks pretty different if it's a fraction being turned into a percentage, but if you've got a decimal being turned into a percentage, usually you're just moving the decimal point around a little bit, and that's all there is to it. So we're going to explore percentages and the relationship with decimals and fractions in the next lesson or two. So I just wanted to remind you guys of that briefly here. Now, because we've gone through all of these topics, and I said I didn't want to give you guys any like word problems or examples or anything like that in great detail today, that's it for today's lesson. And in the next lesson, we're going to go through some examples. We're going to work with decimal addition, subtraction, multiplication, and division. And then time permitting, we'll do some word problems, and maybe we'll get started on percentages, or percentages will be 2 classes from now. So if you guys have any questions, leave me something in the comments or send me an email, Instagram message, whatever you need to do to get in touch with me. And I will see you all in the next video. Have a good one.